Every electrician and electrical contractor understands that proper installation and maintenance are vital to the safe operation of electrical equipment. There is one type of installation where safety depends on a unique set of features in the electrical equipment: hazardous location installations. Crouse-Hinds Electrical Construction Materials, North America's largest manufacturer of hazardous location equipment, has a common interest with all electricians and electrical contractors in helping ensure that hazardous location equipment is properly installed and maintained. Today, we will discuss the design principles of hazardous location equipment and demonstrate how it works. We will then review what needs to be done to ensure the equipment is properly installed and maintained. Hazardous location electrical equipment is very widely used to protect electrical equipment in atmospheres containing explosive gases and vapors. The equipment is designed, manufactured, and certified to stringent safety standards. However, with all the care that goes into the design, manufacture, and certification of this equipment, it must then be properly installed and maintained. Carelessness or mistreatment can defeat the safety features of this equipment, and the consequences can be disastrous. Explosive mixtures of gas or vapor often occur during the normal operations of many facilities. In these locations, enclosures are designed to contain an internal explosion of a gas or vapor without rupturing or releasing the burning or hot gases into the surrounding atmosphere. Enclosures breathe when pressure changes due to fluctuations in temperature and atmospheric pressure. Flammable gases or vapors in the surrounding area can enter the enclosure through the joints, creating an explosive mixture. The design assumes that the explosive mixture of gas or vapor will fill the enclosure. During normal operation, many types of electrical equipment produce arcs or sparks, which have enough energy to ignite gas or vapor in a hazardous location. If it is ignited by the electrical equipment, the enclosure is built to withstand the pressure of the explosion without rupturing and without transmitting the explosion to the surrounding atmosphere through its joints. An enclosure is usually made of a cast metal alloy. The thick walls ensure that the enclosure will withstand the force of an internal explosion. The joints are either threaded or machined flat to create a controlled flame path which prevents an explosion of the surrounding atmosphere. The metal surfaces absorb and conduct away some of the heat. There is also a refrigeration effect as the gases pass from the high pressure of the explosion to atmospheric pressure. There is additional cooling of gases as they mix with the cooler atmosphere outside the enclosure. All hazardous location enclosures are carefully designed to strict standards that include large safety factors. The manufacturing process starts with the pouring of a casting. During machining, particular care is taken to ensure that the joints are flat, smooth, and free from defects. Entries are carefully drilled. And tapped. Inspections are carried out on flat joints, entries, and threaded joints. Every design is tested to ensure that it can hold pressure and contain an explosion. First, we determine the maximum explosion pressure that can develop inside the enclosure. An explosion-proof window has been installed to allow you to see the explosion inside the enclosure. An explosive gas-air mixture is piped in, and a spark plug is used to ignite it. The pressure is measured with a pressure transducer and plotted on a chart. This is followed by a water pressure test, in which the enclosure is subjected to a pressure of 4 times the maximum explosion pressure. Another test is performed to confirm that the joints will prevent an ignition of the surrounding atmosphere. In this test, the enclosure is surrounded by an explosive gas mixture inside a plastic tent. Note that the internal explosion is not transmitted to the outside explosive mixture. Now, we will deliberately damage the flanged joint to demonstrate what can happen if there is an explosion with a damaged flame path. The electrical installation code requires that seals be installed in conduits and cables in hazardous locations. This is done to prevent explosions from passing from one enclosure to another, or to prevent gases and explosions from being transmitted from a hazardous to a non-hazardous location. If an explosion passes from one enclosure to another, pressure piling can occur. This means that the pressure is increased in the second enclosure before ignition occurs because the flame front pushes the unburned mixture ahead of it. To demonstrate, 2 enclosures are connected together with a properly poured seal in the conduit. We will explode the gas in the enclosure on the left to see the effect on the pressure in the enclosure on the right. The explosion is not transmitted. With an unpoured seal, the explosion is transmitted to the second enclosure, and the pressure in the second enclosure is definitely higher. Although the enclosures have been designed with large safety factors, the cascading of the explosions creates a risk that an enclosure will rupture. The absence of a properly poured seal between a hazardous and non-hazardous location is even more serious. In this demonstration, a hazardous location enclosure is connected to a standard electrical box with an unsealed conduit. The explosion is transmitted to the box with very serious consequences. That's why seals are so important. Joints, seals, entries, and instructions. These are the key elements of a hazardous location installation. Care must be taken by the installer and maintenance electrician to protect the machined joints. Covers must be handled carefully so that they are not damaged or dropped. Cleaning the joints ensures there will be no dirt in the joint to prevent it from closing properly. A thin layer of grease can be used on a flat joint to protect against corrosion, and on a threaded joint for corrosion protection and to guard against binding of the threads. Some joints also contain O-ring seals to prevent moisture from entering the enclosures when they are used in outdoor locations. Make sure they are properly seated. If a joint becomes accidentally painted or corroded, clean the joint with a solvent and a clean rag. And if that is not sufficient, A fine emery cloth or fine steel wool may be used. Never attempt to remove the paint or corrosion by filing or scraping. This could damage the joint. If necessary, the enclosure should be sent out for repair or be replaced. And of course, all bolts must be installed and tightened to maintain strength and flame path integrity. A good precaution is to check all flat joints with a feeler gauge, and threaded covers must be fully engaged. To prepare a seal, the conductors must first be separated and a fiber material packed between them to act as a dam. Then the sealing compound is mixed with water according to the instructions and poured into the seal opening until it is full. The compound should be puddled to remove air bubbles and voids. This is a cross-section of 2 seals. The bottom was properly poured. The compound completely fills the sealing chamber. The top seal was improperly poured. An opening was left through the sealing chamber. Some devices have built-in seals and do not require additional seals at the time of installation. These devices are always marked factory seal. In some cases, enclosures are designed and certified to be drilled and tapped in the field. In this case, care must be taken to ensure that the correct drill and tap are used, and that at least 5 full threads of engagement can be made with the conduit. To properly field drill and tap a conduit entry, mount the enclosure rigidly before drilling. Drill a pilot hole, then finish drill and tap. Many junction boxes and enclosures have a number of conduit entries. This allows a single design to be used in many applications. Often, all of the entries are not used. Make sure that all unused entries are fitted with properly threaded plugs. Installation and maintenance instructions are provided with hazardous location equipment. They contain a lot more information than we've been able to cover here. The instruction sheets and labels on equipment are there to help you. Every time you install or maintain a hazardous location device, remember all the care and attention that went into its design and manufacture. Make sure that you are doing your part to keep it safe.